Hello, everyone, and thank you for joining us for this session from Day Zero to Production with Azure Container Apps. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenter to answer. The session is recorded. It will be available to view on demand in 24 to 48 hours. With that, I'll turn it over to Chris. Chris, thank you so much for joining us today.
Thank you, Anna, and thanks for having me. And hello, everyone. Yeah, so thank you for joining this session. Let's just get started. So first of all, this is the typical who am I slide, but I decided why not to put a random title on that slide. So now you also have a binary code puzzle to crack in your free time if you're into that. But just a few words about me. My name is Kristina Devochko, and I'm a platform engineer at Tieto Microsoft Azure MVP and CNCF ambassador. And I am working basically with all things cloud native, Kubernetes, containers, and Azure. And Azure Container Apps is also a part of that. And I do a bunch of different things for the tech community. So if you would like to reach out to me and have a chat about Azure Container Apps, for instance, or any other topic from the domains that I am working with, I'll be happy to have a chat with you. So you can reach out to me to any of these links, where I also have my tag blog, where I put some additional content on these topics as well. And the QR code will also give you that contact information where you can reach me after the session. All right, so Azure Container Apps. If we take a little look back on the reason why Azure Container Apps can be an alternative for quite a few companies and use cases out there. During the recent years, we have seen how Kubernetes has really taken off in the cloud native space. And it has taken off so much that it has kind of become one, if not one of the most important golden standards on how you would build a cloud native platform to run your applications and solutions on top of. But the thing is that throughout the years, it has been talked about so much that this is the best tool, the best solution to go for, that many companies have done that and realized with time that the complexity of Kubernetes in terms of administrating that, in terms of the knowledge that is required in order to really truly succeed with Kubernetes, even with managed Kubernetes service, that is a service offering from public cloud providers like Azure Kubernetes Service, it really takes some good planning and efforts, long-term efforts from a company that you need to account for. And also, many or quite a few applications may not have Kubernetes as the most well-suited platform in terms of different aspects like cost and, once again, maintenance. And therefore, the reason for that, Kubernetes may not be suitable for every scenario. Other options popped up. And one of them is basically Azure Container Apps. Azure Container Apps does use Kubernetes and AKS under the hood, but it kind of is a serverless solution that basically abstracts the complexity of Kubernetes for the consumers. And Azure Container Apps kind of makes it easier for you to start out with just getting your containerized application up and running on containers and still being able to scale efficiently and maybe even scale down to zero when there are no requests coming into your application, and providing basically a lot of functionality that you would otherwise build and operate from scratch yourself out of the box. So the whole point behind Azure Container Apps is to provide a container as a service offering that could abstract all that complexity and the effort it takes with building your Kubernetes clusters yourselves, and instead focusing on kind of making your containerized applications getting out there into public cloud as fast and efficient as possible. And therefore, the big advantage behind Azure Container Apps, which you will often hear if you ask about that, is that it provides you easiness, an easier way to adopt it compared to, for instance, Kubernetes, because there will be also less infrastructure for you to maintain and operate. But there are a few things that we will see throughout this presentation today that will be important to think about when we opt in for a serverless offering like Azure Container Apps. It is an opinionated implementation. There are many tools that are available for us as part of Azure Container Apps that are coming from the cloud native and CNCF landscape, like we will see later, like KIDA for event-driven scaling. But that means that in case you need some specific customizations or some specific tools, you may not be able to do that as part of Azure Container Apps, because you will not have access to the same level of customization as if you would have had if you would have been running a managed Kubernetes service like AKS. So when you are planning and evaluating the options for your use case and your applications, you should remember about the trade-offs and kind of try to map them towards your own use case. As we always say, there is a trade-off, therefore it's very challenging always to say that this is the solution that would work for all, and that's what kind of happened with Kubernetes at some point, but we now talk a lot about that it is not necessarily a solution for all, and the same applies for Azure Container Apps. If we now start to drill down a little bit into the details, the technical details of Azure Container Apps, the most maybe important thing to start with is that when you start working with Azure Container Apps, you would need to think about what kind of plan you would like to opt in for. There are two plans for Azure Container Apps. The one that is called consumption-based. It is basically the plan that you get by default, and normally is a good way to start when you don't have any specific hardware requirements for your application or do not require some additional services related to security, which we'll talk a little bit about later, like integration with application gateway and web application firewall, or integrating user-defined routes with Azure Firewall. These, when you don't have those specific requirements, consumption plan can be a good way to go, and it's also a good way to start with and see if you need to adjust that with time. But another plan that is also available, it is called dedicated plan, and it is based on workload profiles. In the dedicated plan, you could also have consumption-based workloads, but you could also have workload profiles. And those basically can be used in case you have applications that have specific hardware requirements. If you have an application that has very specific requirements for CPU and memory utilization, you may need to opt in for a specific workload profile where consumption plan cannot offer you that. And as part of the dedicated plan, you get those additional services like integrating Azure Container Apps with application gateway or utilizing user-defined routes with Azure Firewall. And there are also opportunities to use to get some a bit more predictable cost by utilizing dedicated plan, especially if you have an application with a very expected throughput. So you would like to have some predictability in terms of cost, because when it comes to consumption plans, you have the way of billing based on how much memory, CPU your container apps are utilizing, and how many requests are being processed by the applications, and also there is some billing when the container apps are in the idle state. So with dedicated plan, you can get a bit more fixed cost and a bit more predictability there. So this can be also an option to consider. So if we think about the use cases, there are quite a few services in Azure that are available for us to run containerized applications on. So it's not just Azure Container Apps and Azure Kubernetes Service. But if we think specifically about Azure Container Apps, some of the scenarios are also available in the Microsoft documentation, and I think it's a nice illustration that we could also bring up here. So very typical use cases where it can make sense to utilize Azure Container Apps is when you have some specific services that do some background processing and can, for example, be run as jobs. If you have some lightweight public API endpoints that you would need to host in a containerized manner, some event-driven applications, and some distributed applications like lightweight microservices. Especially if you have stateless microservices, this can be a really applicable solution to go for Azure Container Apps. But there are also possibilities to host stateful container apps as well. But of course, stateless, if you have stateless applications, that could definitely be a solution to go for. And there are some also use cases where you could use, if you have a need for self-hosted build agents, for instance, you could utilize Azure Container Apps that would basically act as the self-hosted agents that would run the necessary builds and then scale to zero, scale down when there is no work that is needed. So there are some options there that are available for you. And there is also a good comparison at the Microsoft documentation with other offerings like App Service for containers and Azure Container Instances. So if you would like to learn more about that, there will be a link available for you afterwards. But if we take a quick comparison between Azure Container Apps and Azure Kubernetes Service, the most important differences are that Azure Container Apps is fully managed by Microsoft, whether in Azure Kubernetes Service control plane is managed by Microsoft, but you would still be responsible as a consumer for user workloads and also for upgrading the Kubernetes cluster, including the control plane, and also setting up the necessary tools and kind of operating it long-term. So you need to account for that in terms of resources and competence as well. While in Azure Container Apps, you can focus mostly on configuring those containers so that they have the necessary configuration available when they will be up and running as Azure Container Apps. But at the same time, Azure Container Apps is a more black box solution and has some opinions in terms of tool choices and functionality that is available. And even if you request a specific functionality, it may take time before it comes out in preview and also becomes GA, which is worth to think about. And the same comes to like customization. In solutions like Azure Kubernetes Service, you may get access to define custom resources, and you get direct access to Kubernetes API, but you do not have that in Azure Container Apps. And With AKS, you, of course, need quite extensive Kubernetes competence still in order to be able to understand how all the things hang together and how you can implement it in the best possible manner. And with Azure Container Apps, I can't say that, I mean, you can probably, you can start without not having any knowledge about Kubernetes, but I would still, from my personal experience, recommend to get a bit of insight into some foundational Kubernetes knowledge about the different components and how they work, because it may make it much easier for you when you will be configuring the Azure Container Apps for your applications, because some of the same terms that come from Kubernetes ecosystem are available as configuration properties when you are setting up Azure Container Apps. And that specifically becomes relevant in production scenario where you would need to understand what those configuration properties are. So I would recommend still to have some foundational Kubernetes knowledge, but you can also start without it and learn by doing, of course. And the most important thing is to think about your application needs and remember that the in-house competence and the time it takes to get there, for example, with getting truly hands-on with AKS is also a cost. So it needs to be accounted for when you kind of compare the solutions that you have available. And you need also to think about the long-term technical and business roadmap. Would you need to kind of extend, would you need that customization at some point? How many applications will you have? And what those applications require in terms of configuration, and that by thinking about that, you it would make it easier for you to see if one of these choices works better than the other. So now let's drill more down into the technical details of how Azure Container Apps work. I will try to give a bit of introduction so that if there are some folks in the audience who are beginners, I hope that this could help you a little bit. So the way Azure Container Apps work is, first of all, you have something called an Azure Container Apps environment. And this basically is a resource that provides a secure boundary around one or multiple container apps that will be running inside that environment. And if we think in Kubernetes terms, you could think that this is a cluster this is a cluster for your containers to run in a Kubernetes cluster. So this is kind of what the environment represents. And then you can have one or more container apps running inside that environment. And every container app represents your application. Also, Azure Container Apps use something called revisions, and this is used to have some kind of version management that can come in handy when you would like to utilize things like traffic splitting and blue-green deployments. So every revision represents a specific snapshot or a specific version of your container app. And you can have a single revision when there is always one revision that is active, and every new change you add to your container app, a new revision is being created, and there is always one revision available at a time. Or you could have multi-revision mode, where you could have multiple versions of your container app up and running. And every revision can have one or more replicas or copies of your application running as part of that. And if you are familiar with Kubernetes terms, in the same manner, you could have sidecar containers. So you could have use cases where you may have multiple applications or multiple services running inside a single container. This is also supported here. So you may have init containers that will perform some kind of actions before the main container, the main application starts up. And you may have sidecar containers that may be running side by side with your application and doing things like, for example, log extraction. Yes. And now if we think about some of the limitations. I have been working with Azure Container Apps for some time, and these are a few limitations that I would like to highlight in this session that I think could be useful also when you start trying it out for yourself. As I mentioned earlier, Azure Container Apps do not provide access to underlying Kubernetes APIs and to the control plane. So in case you need to create things like custom resource definitions from the Kubernetes ecosystem, you will not be able to do that with Azure Container Apps because it may require access to the underlying Kubernetes APIs. So it may be important to think about that, especially in the cases where you may be migrating application from Kubernetes or AKS to Azure Container Apps. So you would need to look into how it was set up in the Kubernetes scenario. Another point is that if you have Windows containers, those are not supported on Azure Container Apps, but there are alternatives, for example, running a mix with where you have Linux applications running on Azure Container Apps, and then you have Windows applications running on Azure Container Instances. That is a possibility. That is a working possibility, which I've also implemented earlier. And I will be adding some examples for that in the repo, which I will share with you today, but it's currently, so this specific use case is not available there yet, but it will be coming. So you could reference that in case this is applicable for you. Another point that is very actively discussed in the Azure Container Apps community is the support for URL and path-based routing, which is currently not available out of the box in Azure Container Apps. So if you're familiar, once again, with how in Kubernetes this works, you could kind of also configure on the ingress object level, depending on the path where the request should be routed to which specific service or which specific application. And this is not quite available out of the box in the Azure Container Apps configuration, but there are some alternative ways you could do that. So one of the ways is to use proxy servers and make them running as part of your container app or as a dedicated container app. And examples are Nginx or YARP, for example, for .NET applications. And there is also a blog post that I will link that describes how to do that. And there is also one of the use cases in the same repo, which will be coming, where you could take a look at how this can be done. And another limitation that I would like to highlight is that privileged containers are not supported. And privileged containers are those that would require your application to have access to the underlying host or maybe running as a root user. So these scenarios are not supported, and this is, in my humble opinion, a good thing from the security perspective, because this is also the best practice when we are building container images or are utilizing third-party container images, looking for those that are minimal, that are rootless, or are all in all unprivileged is the best practice in general. So this is kind of an opinionated limitation that is worth thinking about when you're evaluating your container images that would be using Azure Container Apps. All right, that was a short introduction, but as I said, this would be a little bit more demo-focused session. So I have prepared a few demos for you that I would like us to dive into. Let's see. All right, first thing I would like to show you, which is not a code demo just yet, but let's first briefly mention how you could quickly start playing around with Azure Container Apps. There are quite a few ways you could do that, and I just wanted to highlight these quick starts that are available here in Azure Container Apps documentation, because there you get all the possible ways you could quickly start using that even before you start working with infrastructure as code. So you could basically do it, of course, throughout the portal and throughout the command line, but you can also deploy your application as an Azure Container App even without having a Docker file, which is typically where you define how your container image would be built. And in that case, when you don't have a Docker file, an underlying technology called build packs will be used to kind of do and create that container image for you. And this is also the case when you And you can even deploy from a local file system or from an artifact. And you can also run the jobs, which is one of the options that are available in Azure Container Apps. You could also do that locally. And if you are using Visual Studio Code, as I do, if you install, if you don't have it yet, but if you install Bicep extension, you could also, if you are already working with infrastructure as code for Azure Container Apps, you could also not use any command line or portal at all. You could deploy your code by just right-clicking on the main Bicep file and basically just deploying whatever you need directly from your IDE. So there are quite a few opportunities that you could use for kind of starting quickly out with local development. And I think if you haven't been to the session that was yesterday, Jonah Anderson was also talking about Azure Developer CLI, which you also could utilize for starting out with Azure Container Apps quickly. So this is also an opportunity for you to check that out. So that is a brief mention on how you could start working with Azure Container Apps locally. Now, the first demo I would like to show you, and then we would need to quickly get back to the slides. Let me see. Oops, sorry about that. Let me get. Oops. There you go. So the first demo I would like to show you is how you could do traffic splitting and utilizing the multi-revision mode in Azure Container Apps. And for that, we would need to just understand how this works. So as I earlier mentioned, with a multi-revision mode, you would have 2 or more revisions of a container app running simultaneously. This allows you to perform things like blue-green deployments or traffic splitting. So for example, when you deploy a new version of your container app, you may not want to, for your users to kind of being routed to this new version of container app straight away. You may want to do it gradually, or maybe you want even to perform some A/B testing without having that version available to any of your external users. And for that, a multi-revision mode could be really useful, because when you're using single revision mode, which is the default one, what happens then is that it follows the rolling upgrade rule. So every time you have a new version of your container app that you're deploying, it spins up a new revision of your container app, runs through the health probes, checks that everything is good and this version is ready to receive traffic, and then it reroutes 100% of the traffic to this new revision and brings down the previous revision. So you can't do any rollback, like straight away, for example, from the portal or from the CLI. Then you would need to go and kind of go through this process all over again and change the version and redeploy and all that. But with multi-revision mode, you can have, for example, the one version that gets 100% of traffic, and then you spin up a new version of your container app. And then at the same time, you define, okay, for the currently stable version, I would like to still have 80% of my traffic going to that. And now I want to expose some of my users to this new version and see if I get any errors or if there is anything shady going on with this version. And then you could define this type of traffic splitting between those different revisions. And in that way, you could have this kind of a bit more secure way of rolling out new versions on Azure Container Apps. Or you could even do a blue-green deployment where you could have one set of your container app that is active and stable and running, and then you could have a new version spun up that does not receive like any traffic, but it gets spun up, and then you can run the necessary test. You expose it to some internal QA team, for example, and if it all looks good, then you in a controlled manner can switch the traffic over to this new version of your container app. So today I would like to show you how the traffic splitting works. So for that, I also mentioned that there will be quite a bit of Bicep code. So if you're not familiar with that, I will try to kind of make it digestible, but all this code, it will be available for you in the repository, which I will share afterwards, so you can go and dig down into it. And it also has the instructions that should help you to understand what kind of modules, Bicep modules, are here, what kind of resources it provisions, and what you need to do to test it out for yourself. So what I have prepared here, we can go to the resource group because I pre-deployed it so that we could spare some time. We have a small Hello World resource group. We start with a bit Hello World first before we increase our level of complexity. So in this Hello World group, it is very simple deployment of Azure Container Apps, where we have just the Log Analytics workspace and an Azure Container Apps environment, which currently runs a single instance of a container app. And that is a simple Hello World container app. So when you provision for the first time, you always get a single one first revision provisioned first before you start deploying some new versions, even in the multi-revision mode. So if this one is provisioned for the first time from the ground up, so if we go to the revision and replicas here, we could see that we have a single revision right now that is running, and that is getting 100% of the traffic, and it is active. So if we go back and find our URL here, we could see that it is up and running. Very simple. Yes, it has an AKS icon, but that was a really nice demo application to use that. That's why we say that it's an Azure Container App. So I'm not trying to lure you. So if we go back to the code, and now we would like to introduce some traffic splitting. We would like to make some change to the application and then distribute traffic 50-50 to see how the new version works. So now I go to the Bicep module that defines my Azure Container App resource. And if I scroll down a little bit here, I could see that it has active revision mode set to multiple, which means that it will have multiple revisions active. And then we could make some change to the application. So let's update this environment variable so that we could define and distinguish between them when we will be performing the test. So we will update this environment variable and then go to the parameters for our deployment. And we will see that there is one parameter that represents traffic distribution. And currently it is set up in a way that the latest revision always gets 100% of the traffic. But now I would like to update that. I would like to have the currently active revision getting 50% of the traffic. So first of all, I would need to get my revision name for the currently running revision and just copy that. See? And then we can paste that in this block. And it will be getting 50. And then the next new version of the app I will be deploying right now will be the latest revision. And that one I also want to get 50% of the traffic. So now we are prepared. And this traffic distribution parameter, it will land in the same definition for the container apps. Let's see. It is also located here under ingress configuration. So this is where it will be populated. So let's now add this so I can at the same time show you how the GitHub workflow looks like. So let's say we introduce new revision. Doing some live coding is always fun. Now, we get back to the GitHub repository where all of this code is located. So we could just go to the actions here and see that I got a new GitHub action workflow triggered for this change automatically for me. So it will run for a few minutes. But if you are also curious to see how the GitHub action workflow looks like, you could go in the same repo to the GitHub workflows and see also how this looks like in practice. And right now I'm doing this manual change. And for some use cases, this can be enough by doing this in a very controlled manner and updating the traffic distribution also in a controlled manner. But you could take it a step further. You could have your workflow also spinning up and doing a truly blue-green deployment, spinning up a new version of application, running some automated tests, updating the version based, for example, on the commit hash or on the semantic version that you may be following, and then switching the traffic automatically as part of the same workflow. So this is basically dependent on what limitations and what processes you have in your organization. But here I have also linked an example of how a full automated blue-green deployment may be done. And this is available in the repository that Microsoft has created. So you could take that as a source of inspiration as well. Also, another thing I would like to mention when it comes to revisions is that you can also, instead of automatically distributing real-life traffic between different versions of your application, you can also introduce something called labels. So you could label a specific revision, a specific version of your container app with a specific label of your choice, and then it will get its own hidden kind of secret URL. So that revision will not be actively available through the public URL of your container app. And that URL can be shared with whoever will be doing the test or with whatever tests that may be done automatically, so that you could have that way of performing the testing as well. And then you could switch the traffic once you perform the testing in that manner. So this is also an option. So you could even combine labels and traffic splitting together. But this is also an availability. Now let's see. I think it should be done right about soon. Let's give it one more second and see. It seems like it's done. Yeah. All right. So if we go back to the container app again and take a look at the revisions and replicas here, now we can see that we have 2 active revisions running at the same time, and this is the one that has been deployed a minute ago, and they have 50-50 traffic distribution. So let's test this. If I just go to this URL again and try to do a few refreshes, I could see that the traffic is distributed evenly. And then I could even go back here and go to, for example, metrics, and I could, for example, see if I have requests, check the requests, and maybe even apply splitting by a revision. And then I could see and compare, for example, versions. If I'm doing some performance testing, I could compare that between the different revisions as well. All right, we don't have much time and I have so much to tell you, so we need to jump to the next demo. And then in that case, will need to go back to the slides again and show you the next demo, which is more closer to production. So what this demo will be about. Once again, there is a lot of information here that I am trying to share with you, but all this will also be available in the repository, which you can take at your own pace after the session as well. So I decided for this session to do a little bit of an experiment and share the learnings with you, and at the same time share how in real life you may be migrating an application to a service like Azure Container Apps, and what kind of things you can discover as part of that. So Microsoft at some point created a demo application, a microservice-based application that represents a shop where you could order products and have some administrative efforts in terms of processing the orders that are coming in and so on. And this application was initially created for Azure Kubernetes Service. So that was Kubernetes native application. So what I decided to do is that I took that application and I migrated it to Azure Container Apps. So how will this look like in the Azure implementation? I also took into account that we may have security requirements, and we would like to run it with a bit of additional security. So how would this look like in real life? And there are a lot of components here, which we will see a little bit at how they look like in real life. But what this represents is that we have two publicly available applications running as container apps. Storefront represents the shop, the product website that is publicly available for any external users that may want to access it and buy some products. And then we have another publicly available container app that is called Store Admin, and that represents an administrative service that employees can access in order to see what kind of orders that came in and process those orders. And for that one, I wanted to introduce some authentication because I want to ensure that not everyone accesses the admin page of our shop. And for that, we have multiple options, but in this use case, I have enabled the authentication feature on Azure Container Apps, which we will see shortly. We also have a bunch of internal container apps that are used to create orders, create new products, process orders, and so on. So all of these container apps are only available internally and are not publicly accessed. We also have some managed services in Azure that we are utilizing. All of them are accessible only through private endpoints, including Log Analytics Workspace that will be used to kind of gather all the necessary logs from the application and also the system logs for container apps and container app environment. It is also accessible through Azure Monitor Private Link Scope, which is a service that provides private endpoints in a more efficient manner for Azure Monitor services. And the same goes for Key Vault and Azure OpenAI, which is also used by one of the services to help us create new products with help of some AI capabilities. All of this is deployed in a Azure Container Apps environment that is behind a network security group and uses a custom VNet as well that has also been created as part of this implementation. But there is always an option for you to use a automatically created virtual network when you create an Azure Container Apps environment, but you need to be aware that it has limitations. It can't be managed by you, and it only has access to public endpoints. So for example, you can't utilize private endpoints or introduce a network security group with an automatic virtual network. So that would only work if you have a bring your own network configuration. Yes, and all of that is deployed in a resource group. Yes, before we go to learnings from that, I would like to show you how this looks like. So let's take a look. There are many resources there. I will not go through all of them due to the lack of time, but that you can check afterwards as well. Let's just see how it looks. First, we will go to the Storefront container app, which represents our public website for the store. So I will just open it in the new tab. And here you can see I have a bunch of products that came out of the box. This one I created prior to this session. So I could, for example, choose from them and add them to cart and check them out. And we will also open the admin service, and that is to illustrate you that I am actually doing some real logging in. So it is utilizing Microsoft Entra ID as my identity provider. So I will now log in. So as you can see, that is the first thing I got is the requirement to log in, which means that authentication is running as expected. Let's sign in. And I get access to the backend of my application, and there is some automatic processes running in background to simulate some traffic. So I'm getting some orders in, but let's create a new product and see also the Azure OpenAI in action. So let me do some notes here so that it can go faster. Let's create a new product, the card box for the cats. And let's give it a price of 10 something something. And let's get it some keywords. And now I would like to ask Azure OpenAI to generate some description for me. And it does that. And I would also like to add the picture to it. And then we can save the product. There you go. Oh, it did populate the picture. So now we can see that we have a new product here up and running. So we could go back to the store and make some orders. So I would like some catnip and a card box for my cat. And now let's check it out. Now we can see that order submitted successfully. So we could go back and see if we get some new orders popping up. And the last one here is ours. Catnip, cats, card box. So I could just complete it. And that's how the application basically works behind the scenes. So pretty simple. Of course, this is not a production level application, but it is something more than just a hello world. So here we could actually do some more things that you would need to do when you're actually doing it in a production-like scenario. And now I would like to show a few things, a few highlights that you can take away with you when you will be doing this for the production-like scenarios. So now we have seen how the application is architected. So we could take a look at some of the things that you would need to think about when you would implement something like this with Azure Container Apps. So first of all, we will need to take a look at some things in the Container Apps environment. So one thing that can be relevant to think about is if we go to JSON view here, it is not available in the UI in an easy manner other than here, but I would just like to show you that there is a configuration available on the Azure Container Apps environment level that is called Zone Redundant. And once you enable that, it provides you the capability to distribute the replicas of your container apps across availability zones in a specific location. And that would give you most value when you have more than 2 replicas, ideally 3 replicas of your container app. And you can enable that even if you have a min replica equals to 0 or 1, because if you scale out at some point, then those replicas will be distributed with the zone redundant property enabled, and it will not incur any additional cost on you. So this can be one thing to think about when you are implementing that. Another interesting thing to think about is MTLS. And by default, when you are provisioning Azure Container Apps, all the traffic, all the TLS traffic is being terminated at the ingress, at the edge proxy, and Envoy is used in the background by Azure. So all the traffic internally is not utilizing TLS, but if you would like to have end-to-end encryption, you could set MTLS to be enabled, and that is also the same property that is available for you in infrastructure as code like Bicep. So if you would like to have that, you could also enable that, but you need to think about that if your application has very specific requirements to throughput or performance numbers, this may affect it because you would need to encrypt and decrypt traffic for every container app that communicates with each other and with the edge proxy. So, but this is also an option. You could also bring your own domain and your own domain instead of utilizing what the default one that we have seen on the container apps, like here, for example. You can also use your own domain, and you could either use the free managed certificate, TLS certificate for that domain powered by Let's Encrypt as part of this, or you could also have a bring your own certificate as well. So this is also an option. I also have capabilities to see system logs for the whole environment if I want, so I could get the whole streaming of those logs up running live for me, or I could go to the log analytics and take a look take a look there as well, and it will provide me some information about how my container apps are doing in this environment. Let's see. Also on the environment level, I can, this is where I would define what kind of file shares from Azure storage account I would like to make available for my container apps to mount. So if I need some kind of data that I would like to keep persistent, I can create some, connect some Azure files from a specific storage account. I can connect them, make them available on the container apps environment level, and then use those to create volume mounts, which again comes from Kubernetes ecosystem, on the container app level. If I would like to have some persistent data that cannot be stored locally in a container, because if it's stored locally, it will disappear once container is restarted, and we need to be prepared for that. And now a few highlights also on the container app level as well that I would like to mention. We could take a look. Let's see, I have only 10 minutes left. Let's take a look at the public container app first. Let's go for store admin, which I mentioned has authentication enabled. So first of all, if we go to the ingress, for example, this is ingress also comes from Kubernetes terms, but this is where you configure if you would like your container app to be publicly available or only available to container apps in the same container app environment. So since it's public, it is available for traffic from anywhere, and it does not allow insecure connections, which means connections over HTTP. So it only allows connections over HTTPS. And if we look at the authentication piece here, it is actually very easy to set up. You just add your provider here, either Microsoft, where it will create automatically an app registration for you, or you use the existing one, and then you are good to go. But you can also add multiple providers, and providers like Apple, Facebook, and others are available here as well. What this will do is that it will also spin up a sidecar container. So you need to kind of think about that. Think about that as well. So once it's enabled, then you may need to have to think about some cost there. So there are also other options available. Of course, if you have authentication in your application already available out of the box, maybe you would want to use that instead. And for the internal container app, maybe the most interesting thing I would like to show you, that once it is marked as internal, it will have a very specific URL here that has an internal prefix. But we could also go to the ingress configuration here and see that it is only accessible by the same container apps inside the same environment. It does not allow any insecure connections. And it is stripped down even further. So it only allows for traffic from the same subnet, and the environment requires a dedicated subnet for all the container apps in that environment. So this is also added here, and you could even strip it down even more if you know the specific IPs that you would like to restrict it to. You could also do it here. And last thing I would like to mention is the secrets. So once you will be looking at the Bicep code, for example, there are opportunities to either send the secret as part of the configuration directly, and then if it's utilized as part of environment variable, you will be able to see it in clear text. So for example, if I go to RabbitMQ here, I may be sending those secrets directly. And even if in the Bicep code itself, I am getting that information in a secure manner from the key vault. Let's see, get secret here. So I am retrieving it in a secure manner so that it doesn't pop up in the logs. It still is available in clear text here, but I have a better option, so it makes sense to do it wherever you can. If you can store your secrets in the key vault and retrieve the URL to that secret in the Azure Key Vault, then you could use it as a secret reference, and then it will not be available here to see. So in here, in the secrets for that container app, I could see it being a value to a URI to that secret in the key vault. And if I go to that container and check the environment variables, it does not have the real value in it. It only has the reference to the secret name. So that's why it will not be kind of available to you easily in the portal here. Yeah, there are a few things that I see. I only have 5 minutes left that I also wanted to mention, but time flies fast. So you could also check that in the repository afterwards as well. But a few learnings. I think we can cover a few learnings from that migration that can be useful for you to think about as well. If you have an application that requires some configuration, like key value mappings, for example, in the Kubernetes universe, you have the resource called config map, and that is not supported in Azure Container Apps at this point. There is a possibility to do workarounds like saving it to a file and then mounting that as a volume on your container app. And you will see that information in the demo application. Also, there is no possibility to configure CPU and memory limits for the container app, even on a very, very granular level. So you have a specific table that you need to account for, where you need to plan the combination of specific values between CPU and memory that should that out of those that are available in kind of available mix and match table. So I will share the link afterwards to that, and therefore you will need to kind of adhere that if you would like to configure CPU and memory limits on your container app. As I mentioned, URL and path-based routing is not supported out of the box. And if you have a container image that has Nginx and that configuration is specific, like in this use case, it was specific because it had hard-coded ports. So I either would have needed to open up an additional port to allow this built-in Nginx configuration to work, or there are also workarounds here where you could also take the Nginx configuration if you are in such a situation, and then you update it according to your needs, and you also mount it either as a secret or as a volume from the storage account, and it basically overrides the default Nginx configuration that comes from the container app. So it is also possible. Also, you need to think about secrets management, especially if you have private container registry. Azure Container Registry gives you opportunities to use managed identity, but if you're using Docker Hub, for example, you need to think about how you store those secrets so that they don't pop up in clear text in your infrastructure as code templates. And you could utilize some examples from the repo later. And all in all, the application behavior will be the key to success here. So you would need to potentially make some refactoring to ensure that it works, and it works natively for Azure Container Apps and does not require much workaround. And that solution that is available in this repo, you could also take it even further. It can be integrated further. Besides private endpoints, you could also integrate things like web application firewall and Azure firewall, for example, or even implement a traffic manager or a front door to distribute traffic also across regions so that you get the geo redundancy in place. So, of course, this is meant as an inspiration for you, but there are also opportunities to make it even more secure. And there are some of the highlights that I showed in terms of features that are available for you. Unfortunately, not enough time to show it all, but there are also more features like Doppler, for example, that will be, we have a separate session on that from Stas that is coming up, I think. And also some other features like utilizing open telemetry to ingest data to application insights, for example, or even running Azure Container Apps on Azure Arc. So there is ongoing development that is happening as well. Yeah, so these are some of the sessions as well that will be covered about Azure Container Apps that you are welcome to check out. But the most important thing is that this is the QR code to the repo. Where all this code is available in Bicep. I wish I had more time to go through all of this code, but I think we would need to have a dedicated workshop for that. So you are welcome to just test it out. It is actually ready to just right-click and deploy it to your subscription. So test it out. If you would like to see some additional use cases, you're welcome to create an issue on that repo, and I can see if I can get that reference implemented. There you will also find some links to, for example, Azure Landing Zones Accelerator for Azure Container Apps, and you will see quite a few similarities with the AKS store demo implementation for Azure Container Apps, which is available in this repo. So you could definitely use it as an inspiration to also in combination with Azure Landing Zone Accelerator. Yes, I hope that was useful. I think I tried to make it a bit more digestible for different levels of the audience, but I am open for any questions that you may have, if there are any. Let's see. Maybe I need to check the chat. Okay, I see there is one question here. Does this work without needing a traffic manager? So is this traffic splitting natively built into Azure Container Apps? Yes, it is natively built in Azure Container Apps. It is available as part of the Azure Container Apps configuration. So this happens automatically. This is just the fact that you can use Azure Traffic Manager or Front Door, which can be relevant for some enterprise use cases where you want to have this geo redundancy, or you just want to ensure that you have even more stricter control over the traffic between different versions of your container apps. So both options are possible, and it's not required to use Traffic Manager or Front Door in this case, because it's traffic splitting is available out of the box. Yeah. Are there any other questions? Don't be shy. I see there was a comment that we need lengthy sessions for this, and we truly need that. Maybe there will be an interest for the workshop and we could dive deeper into that demo as well. But at least it's available for you to check out. It's available for you to just deploy and start testing that. And you're also available to create issues if you would like to see some specific use case, and I can see if I can get it to that repo. And the same architecture drawing is available so that you could look into it in more details. But that was a brief teasing during this hour. I hope this was hopeful, and I hope that you can benefit from that implementation that I think is more closer to a more enterprise scenario, and how you would do that with infrastructure as code and security controls and that type of things. All right. Thank you. Yeah, then I think we're done. Anna, back to you, I guess. Thank you everyone for attending.